So today we're going to look at multiplying and dividing fractions in a problem-solving situation. We're going to apply the basic understanding that we did yesterday with multiplying in a fraction of multiplying the numerator and denominator, and then reducing to simplest form. Or if we are dividing, we are going to follow that keep, change, flip. The other piece that I wanted to bring in today was kind of modeling through this as well to help you solve and draw a picture if needed as a strategy. So we have 6 problems we're going to do together and then 3 that you'll do on your own. I will have another video showing how to solve the next 3 instead of just pictures like I did yesterday. So Craig has a piece of rope that is 3 feet long. He wants to cut it into pieces that are 1/3 of a foot each. How many pieces of rope will he have after cutting them? So he's got 1 foot, 2 feet, and 3 feet. So he's got 3 pieces of rope that he is trying to split into. Jumping the gun here. Split into thirds. So we want to see how many thirds can go into 3 whole. So we've got 3 divided by 1/3 equals, we're going to say P for pieces. And we've got 1, 2, 3 pieces, 4, 5, 6, 7, 8, 9. I can get 9 thirds out of 3 whole feet. So we can also follow and do our keep, change, make sure I make that into an improper fraction, flip, so this would be 3/1, and 3 times 3 is 9, and then 1 times 1 is 1, which is the same as 9 pieces. Oops, scrunching it in. So let's look at problem number 2. Lucy's training for a 5K. She decides to run 2/3 of a mile every day. If she runs for 9 days, how far will she run altogether? Well, we've got our 9 days here, and I'm going to show that she is running for 2/3 every day. So I can go through and set up an equation that we've got 9 times 2/3 equals, we'll just say D for distance to see how far she is running. So if we set up our problem as 9/1 times 2/3, we end up with 18/3. I know that 3 goes into 18 6 times. So 18 divided by 3 is 6. 3 divided by 3 is 1. And then I'm left with 6 whole. I can also kind of show this in my image where I can group, so I'm showing 1 whole at a time. For instance, if I've got my 2 here, I can show, let's not use green. That's blending in too well. Let's go fun. So we're going to go, so there would count as 1 whole. Then I've got another whole here. And so I can keep going and grouping them into groups of whole numbers. And then I just happen to end up with 6 even whole numbers. So here would be 1 group, 2, 3, 4, 5, and 6. So she ran 6 miles in total as she was training over the 9 days. All right, so Daniel has a bird feeder in his backyard. He has to fill it every week with half a bag of bird seed. If he refills his bird feeder 6 times, how many bags of bird seed will he use? So we're showing that he has 1/2. This would be, he filled it up 1 time, 2 times, 3 times, 4 times, 5 times, and 6 times. And then they're wanting how many bags of bird seed would he use? Well, 2 halves together make a whole. So then I have 2 wholes, and then I'm left with 3. So we can write an equation that says 6 times a half equals, well, B for birdseed bags of birdseed. So then we've got 6 over 1 times 1 over 2, which would be 6 halves or 3 wholes. So we would need 3 whole bags. 3 bags. So there's 3 different problems. Let's go ahead and look at another set that are a next level up, or having us to think about what is it really asking us to do. So Jesse loves ketchup, don't we all? And puts it on everything. It's a little much. He uses 4/5 of a bottle every 3 days. How many bottles of ketchup will he need to buy for 3 weeks? Well, this is where I have to take what I know. So, okay, 3 weeks we know is the same amount as 21 days. And if he is going every 3 days, so we've got 21 divided by 3, we know that we're having to look at groups of 7, because we're going every 3 days. So I'm going to have to look at this 7 different times. So these are my 7 different groups of 3 days. And we're going to show that he uses, so there's 4/5. And so I'm going to keep going where I'm just showing 4/5. And then I want to group them so I can count and see how many actual bottles he's going to need. So if this would be our 4 here, and then I'm just going to add, so now I've got 1 whole. And let's see, 3 and 2, so there's another whole bottle of ketchup used. 1, 2, 3, 4, 5. Whole bottle of ketchup used. There's another whole bottle of ketchup used. We'll just go this way. Okay, so we've got 1, 2, 3, 4, 5 whole bottles of ketchup that he uses, with 3/5 left over. So 5 and 3/5 bottles. Man, this guy likes ketchup. So in order to actually go through and solve this, if we said I've got 4/5, ooh, hold on, let me change that. That's going to get confusing. So if I have 4/5 times 7, so we've got 4/5 times 7 over 1 is the same as 28 over 5. 5 can go into 28 5 whole times with 3 out of 5